Welcome. Today I will be talking about the all-important electron. Let's get into this. The electron was discovered in 1897 by English physicist J.J. Thomson during investigations of cathode rays. His discovery of electrons, which he initially called corpuscles, played a pivotal role in revolutionizing knowledge of atomic structure. Under ordinary conditions, electrons are bound to the positively charged nuclei of atoms by the attraction between opposite electric charges. In a neutral atom, the number of electrons is identical to the number of the positive charges on the nucleus. The electron is the lightest stable subatomic particle known and is considered the base unit of electric charge. For reference, the rest mass of an electron is 9.109 times 10 to the negative 31st kilogram, which is about 1/1840th of the mass of a proton. Not bad, right? Being a fundamental particle means that nothing makes it up. It's as small as it could possibly be. The electrons are part of the negative aspect of an atom. They rotate around the nucleus of the atom, which is composed of protons and neutrons. Except in the case of hydrogen, because of its atomic number of 1, it has no neutrons, only one proton and one electron, like you see above. The electrons have a charge of -1. Within any given atom, electrons move about the nucleus in an orderly arrangement of orbitals. The attraction between the electrons and the nucleus overcoming repulsion among the electrons that would otherwise cause them to fly apart. As I said before, electrons are a fundamental particle. Now, from these elementary or fundamental particles, there are three categories: quarks, which comprise up and down quarks, which make up the proton and neutrons in the nucleus of an atom; force carriers, which include photons; and then there's the group which electrons belong to, which are leptons. Electrons transfer from atom to atom. If an atom or molecule is left with too many or not enough electrons, then it becomes an ion, which means that the atom/molecule has a negative or positive charge. As I showed in my original model of the atom on the second slide, here on the screen is an example of a sodium atom losing an electron to a chloride atom, making them both ions. The sodium is positive because it has one more proton than electron, and the chloride is negative because it has one more electron. Electrons also have properties of both particles and waves, and so they can collide with other particles and be diffracted like light. Experiments with electrons best demonstrate this duality because electrons have such a tiny mass. In electrical conductors, current flow results from the movement of electrons from atom to atom individually, and from negative to positive electric poles in general. In semiconductor materials, current also occurs as a movement of electrons, but in insulators, electron flow is stopped and no electrical current is allowed to pass through. Here are three good examples of a conductor, semiconductor, and insulator. Without the discoveries of electrons, so many of the experiments performed by scientists today couldn't be performed, especially without the basic knowledge of an atom. One example would be the electron microscope. Without this, we would know so much less about the microscopic world. And just for fun, I attached one of my favorite molecular comics. Haha, feel free to laugh or don't. Thank you so much for listening, and here are my two-sided sources.